Hello everyone, my name is Abdul. Welcome. As I promised earlier, or as I said earlier, so I was going to start a tutorial series in C programming, and I'm going to make it step by step. Okay, so this is our first video. As usual, from the onset when Brian Kennedy wrote his first program in C, and then the first line of statement he printed to the screen was "Hello World." Become a tradition, right? In the programming world, that any programming language you start, not necessarily you have to start with that, but any programming language you start is "Hello World," right? So today we are going to do the "Hello World" of C. So we're gonna see some few features of C, but before we do that, we have to first talk about the some history behind C, right? So C was language that was founded by or developed by Dennis Ritchie. He developed it in 1972, and it was a successor to the B programming language. So for those of you who don't know, there were two other programming languages before it. You have the A programming language, the B programming language, and the C programming language, right? So the C programming language was designed, right, to develop the Unix operating system. So Linux, Mac OS, all types of Linux variants, OpenBSD, FreeBSD, all of them are variants of Unix, right? Although Linux and Mac has gotten very substantial change in the implementation of the Unix kernel, for the most part, everything is almost the same. So especially when it comes to the terminal, the commands, they are almost all roughly the same, right? But there is some substantial differences when it comes to architecture of the operating system and also the some kernel data structures. So apart from that, most operating systems that are compliant to the Unix specification, we call it the POSIX specification, have some relationship. So most of the times it lowers the the learning gap in the sense that if you're a Mac or a Mac OS user or you're a Linux user and you switch to Mac OS, it exposes you roughly to the same programming environment as in the other Unix variants. So it means that they are compliant to the Unix specification. Anyways, enough with that. So C programming language, right? So what is a programming language? So programming language is so when we say a programming language, what do you mean by a programming language? Well, a programming language, as I see it, is a way for you, the programmer, to implement algorithms that the computer can understand, right? So a programming language, it's the language of the computer, not your CPU. So what do I mean by that? Your CPU exposes a set of registers, right? Registers are like high-speed storage, small high-speed storage, and a series of registers and other stuff in the CPU, logic unit, control unit, and other hardware that the CPU exposes for your program to run. But most of the programs we run are high-level languages in the sense that we write them in languages we understand, right? So we need softwares, right, that will translate whatever we say in the high-level language into what are happening in the low-level language for the computer to talk to, right? So anytime you want to run any programming language, you need a programming environment. So if you want to write a Python programming language, right, you want to run it on your computer, you need a Python interpreter. Why a Python interpreter? Because a Python interpreter provides the environment for which the code that you've written in Python is valid, right? If you pass a C code to a Python interpreter, you will see it riddled with so many errors. Why? Because the Python interpreter is not the programming environment for your C program. So for every programming language, it requires a programming environment. And depending on how you implement the programming environments, you come into a different section of computers that we call compilers, right? Assemblers, right? And interpreters, right? So so that's what I'm saying. So the programming environment as implementations can end up in one of these, right? Let me, before C starts to flag it as an error, right? Yes. So programming environment. So it can be one of these, right? It can be a compiler. It can be an assembler. It can be an interpreter, right? So compiler is related to a programming paradigm called compilation, or we call it AOTs, or ahead of time compilation. Sorry, I'll explain that later. But compilers. So what compiler does is it takes your high level language and compiles it into a different set of language. So a compiler doesn't necessarily compile it into, so the general definition for a compiler is it compiles it into binary, but you can have a compiler that compiles to an intermediate language, right? So for example, the Java virtual machine, right? And then the .NET CLI and common language runtime, right? It's implemented in such a way that in order to extend its platform independence, right, any high-level program you run is actually compiled into an intermediate state, right? In Java, it's called Java bytecode, but in C# it's called Microsoft Intermediate Language, MSIL, right? So this intermediate language or bytecode, it's independent of the platform you run it on, right? Then you can port that bytecode to different platforms. Then for each platform, there's an implementation of the virtual machine that is going to run that bytecode. So if I wanted to run Java bytecode on Windows, then I need the Java virtual machine. Means that the Java virtual machine is a virtual computer that kind of understands the instruction set of the bytecode that I compiled from my high-level Java code, right? So what it says you do is you convert your high-level code into an intermediate code, and that intermediate code, it doesn't restrict itself to any platform because it's implemented on a virtual computer. And that virtual computer, you can replicate that virtual computer on the different platforms. So you can replicate it on the Windows, you can replicate it on the Mac, and you can replicate it on Linux, right? Or BSD or OpenBSD, and on and on and on, right? So that's a compiler for you. So a compiler takes a high-level language or a source language, translates it into a destination language. So you can have something. Sometimes you can even have cross compilers, right? So compilers that compile from one language into another language. It's also there, right? So enough about compilers. Assembler. So assembler deals with a more lower level, right? So assembler takes assembly language, and assembly language is the kind of programming language that exposes you to the programming environment of the CPU directly. So it means that if you run a program from assembler and you compile it with the assembler, you're going to get directly into a binary, right? So assemblers takes your binary program and then compiles it to an object code. And you can then pass this object code to the linker to do some resolutions, another term, name resolutions, function resolution, function call resolutions, and other things before you actually becomes a binary. So an assembler is much closer to the hardware because you are coding directly in the instruction set that the processor understands. So your program is directly runnable, albeit with a few modifications on the target platform, or which is in Windows, Mac, or Linux. Then an interpreter. So an interpreter, it's like the Python interpreter, right? You have a series of programming languages program statements in Python, which are text-based statements, right? And you pass this statement to the the interpreter. Now, what the interpreter does is it goes line by line and what translates its text line by line, right? So for every line, let's say you say I is equal to 2. It performs a sort of type inference to know that, okay, I is an integer, and then creates a Python object of type integer, sets the value to 2, and then sets a reference count of 1 to the variable, to the value 2, right? So it does that and converts all of that and stores it in the memory pool allocated by the Python interpreter. So what happens is with the interpreters, it takes statements line by line, and then translates those statements into bytecode, then intermediate machine code, then runs it. Bytecode, then it runs it, right? So basically, that's what compilers do. Interpreters do. So the programming environment you want to run any program with will determine the programming, one of the tools you are going to use to program. So here we are going to do C programming. So definitely we're going to do a compiler. But the compilers, even among the compilers, there are different paradigms, right? So we have JITs and AOTs, right? So we have JIT, right, which is just-in-time compiler. Then we have the AOTs, ahead of time compiler. So generally, actually speaking, the C programming language is an ahead of time compiler, right? The and then the Java compiler and then the .NET compiler, right? They are all GITs. GITs in the sense that they are just in time. So the way GIT compilers work is they work like interpreters, but they have some level of compiling elements to them, right? So they were invented as a performance trade-off between ahead of time compilers and then interpreters. So ahead of time compilers, you had to run the program entirely, right? Compile it entirely into a binary before you can run it. Now, JITs were trying to play smart between the two. So we are trying to get close to the performance of that of an ahead of time compiler, but not sacrifice the performance for the interpreter, right? So you want to get some level of interpretation in the sense that you can translate code line by line so that code runs on the fly. But you also want to make sure that you get the performance of the ahead of time compiler, right? So that's why they invented the JIT. So there's a lot of techniques, profile guided optimizations, and other stuff that they use to ensure performance benefits for compilers. But anyways, we are doing ahead of time compilers. Ahead of time compilers, as the name says, it compiles the code ahead of time, in the sense that you compile the program ahead of time and link it into an executable. Then when you run it, the OS loader will then pass the binary you've created and then run the program directly on the processor. So enough with a little bit of a compilers. We've talked about assembler. So any programming language you use requires a programming environment, and that programming environment is going to specify which tools you're going to use and which programming paradigm you're going to follow, right? So for your information, C is a strongly typed programming language. When we say strongly typed programming language, we mean that if you want to declare any variable, do any form of memory assignment or anything, you have to specify types, right? Types are very important to C. So we'll talk about types next, but before that, let's look at what a C program looks like. So we're going to do a simple hello world program, right? So first thing, just follow me on this, right? I'll explain all of it later. Just follow me. Say hash include, right? stdio.h. So this hash include is something we call a preprocessor directive, right? A preprocessor directive. Now, when you run your program and you're in the process of compiling it, there are steps that happen before the compilation process actually happens. The compilation processes happen where there are translation of your high-level programming language to assembly language, right? But then you have something we call a preprocessor, right? The preprocessor is a software or a text replacement software or tool that runs within your compiler, and before your compiler attempts to actually compile your program, the preprocessor goes through to see these hash statements, and then when it finds them, it tries to replace them in the program, right? So this, what I'm trying to tell it that I have a library I want to use, and that library I want to use is stdio.h, right? Standard input output.h. It's a header file. I want to include some programs, some data structures from this file, right? Because remember, the programming language you are going to use, there's already pre-built libraries, right? You can't only do everything on your own. So you need to get something, you need to include a library that will make your work easier. So that's how you do that. So you said hash include, telling the preprocessor that include this entire header file into my compiled binary, okay? Hash include that. Now, int main, this is very important, right? Int arg count char argv. Don't panic over this. We'll explain it later. Then we'll do printf or put hello world, right? Put hello world, right? Then we'll see return 0. So I explained this one here. So this is a directive, right? We said preprocessor directive. It's a directive to the compiler to tell it that before you run this program, invoke the preprocessor and tell it when it sees hash include, it says, okay, the next statement from the hash include is a library file I should look for and then add it to your program. So this puts function we use here is a function that is implemented in here, the hash include the stdio, right? So it means that we are trying to invoke a library function from the stdio, right? Now this main function here is very important to see. Now if you are running your program, unlike Python, right, where when you start running your program, you just start from the beginning of the file and then start running it line by line. In your C program, you have to tell it where it should start running from. You get me? You have to tell it where it should start running from, right? So you have to tell your C program, okay, when you attempt to run my program, where should you start running my program from? So it's technically called an entry point, right? We'll talk about some advanced C APIs very soon, but for now, let's talk about this yet. So the main function. So the main function is how you tell C that, okay, when you're about to run my program, right? Anytime you meet this function name, then it means that it is where I want my program running to start from. So we call it the program entry point. Now the arguments here, forget about them, right? argc, argv, forget about them. Let's just learn how to run it. I'm using MinGW GCC compiler. You can go online to search for how to use it. So I type gcc.exe, right? And you want it to output the file to a certain destination location. So let's say hello world. Since I'm running on Linux, it will be an exe file, right? Then hello world.c. Sorry, I had to let me go into the directory first. So yes, we have this gcc.exe, compile it and output the compiled executable into hello world.exe, and then the file you're supposed to compile is hello world.c. So here you have hello world.exe. So you are saying -o. That means output to this file and then compile this file for us. So if you run it, take your time. It looked good. So you see nothing happened, right? So now this is the compilation step. Now let's list the file. Let's list the directory, sorry. So realize that we have two files in there, hello world.c and hello world.exe. Now the hello world.exe we said earlier is the compiled program. So now see, let's do this. So this is how you run it, right? Like this, hello world.exe. You press enter. Whoa, it worked. So you could see that this is the very simple structure of a C programming language. This is entirely what you need to get started in C. Clap for yourself. You've done well. You've written your first programming language. Yay! You're going to go and do great stuff from here. So that's a C programming language for you. This is the basic introduction. So you've seen all the main elements you need to see in a C programming language. So we have the preprocessor that we have here, right? So anytime the C compiler sees this hash statement, it looks at the text after it. It looks at the text after it and say, okay, what is the text after it trying to see? So this include is trying to tell it, okay, look at the text next to this line and that name, pick it up, and then go and load the library, right? Because we can't write all the libraries ourselves. And then you say int main, right? The main programming language, I said the main function is a function or something we call the entry point. When your program is running, you have to tell the C compiler, where should I start running my program from, right? When I attempt to run it, right? So the main function specifies where the program execution is supposed to start, right? And you also call the entry point, right? So put hello world. It's like you have a room, right? And then you have a house, a big house, and there are no doors in the house. How are you going to enter the house? You need to have at least one place where there is a door that you can open before you enter the house, right? Good. So it means that with the C program tool, you write all your statements down. The C compiler doesn't know where to start running the program from, right? So you have to tell it, C compiler, this is the door to my program. So it means that if you want to run my program, start running it from here. You get me? Does that make sense? Good. So basically, that's it for the first video on C programming language. The next video, we're going to talk about data types and programming language paradigms, object-oriented, procedural, and functional programming language. And until then, bye. Thank you for watching. As usual, subscribe, follow me, and then I'll keep bringing you great content like this. Stay safe out there. Thank you.